Hello everyone, my name is Jeff Cooper's Ghost. Today we are going to talk about gunsmithing, the break open action specifically. This is a 12 gauge over under Rizzini. This gun came to me from a client who experienced a misfire and broken firing pin. That's the pin that broke. It was the top pin that broke. The bottom is still intact. We're going to talk about why it broke, and how I'm going to fix it. This client bought the gun considerably cheap with hopes of using it as a primary trap gun. He wanted to put some money into it, have it stock refinished, put a new sight on it, and repair the firing pin issue. This is our existing firing pin. We were able to source 2 new ones from Numrich. That's our existing firing pin on the right. The middle firing pin is how they came from Numrich, and on the left is how I've modified one of the 2 replacements to fit the action. We bought 2 in case if they broke once, they will probably, the one on the bottom may possibly break again, so now he's at least got another backup in case one of these breaks again in the future. Let's take a look at firing pin protrusion with the existing firing pin on the bottom barrel. Take a few measurements. You guys can see that first one right there. Let's take another measurement here. That's a considerable amount of protrusion, and I'm just pushing it forward with my finger, holding it flush on the back of on the hammer striking surface. You want about 30 to 50, even 60 thousandths is acceptable. You guys can see this, these firing pins slant in the action. This one tapers down, and then the top one kind of sits in there like that. And when you rotate it the right way, a single pin holds them both in place. Let's take a look at how much protrusion I get out of my modified pin on the top barrel. Let's just take a look at that. That's more what I'm looking for. About half the diameter of the pin worth of protrusion, between half and the full diameter. And we've got about 60 right there. That was about 60. Let's see what the bottom intact pin measures on the top barrel. I expect we'll get 100 or more thousandths. And you guys can see how that slants out of the action. It protrudes at an angle. So I want to take off about 15 thousandths of this thing. If it were to go in the top barrel, we're going to be putting it in the bottom barrel. We'll turn it on the lathe and we'll turn off probably 40 thousandths. We get about still 100 thousandths of protrusion in here, I'll bet. Oh, 75. $80, $81. And this is not a super precise method of gauging protrusion, you guys. I have to make a new firing pin protrusion gauge, so we're just kind of ballparking this right here. So what I'm going to do is polish these up on the lathe a little bit and clean up those old machine marks, and then I'm going to harden them with Brownell's Caseinite or case hardening compound. Hopefully that will retain some of their hardness, and that'll resolve our current broken firing pin issue, but it doesn't address why the firing pins broke, and that's what I'm going to discuss with you guys right now. What causes firing pins to break in break actions like this is a condition called firing pin drag. And what happens is when the firing pin, that one won't work, that one won't fit at all. And our spring's not on there, so that's a considerable amount of protrusion you're seeing. When our firing pin strikes the cartridge and the gun fires, and we need to recock the action, the hammers remain forward, and when the gun opens, the hammers should start cocking almost immediately. If the barrels are able to open a considerable amount while the hammers are still forward, it can cause the action to open and the cartridges to drag on that protruding firing pin while they are inside of the, not inside, while they're recessed into the struck primer. This is called firing pin drag. It drags as the cartridge and barrels open together, you can see how the circumference of that firing pin is going to be dragged and wants to bend inside of its bore. This is part of the cock on open timing for these guns. What we can do is advance the timing on this gun so that the hammers cock sooner on the opening process. I'm going to put this back together real quick for you guys and show you what that timing check looks like. And now my spring is stuck in the action. There it is. Okay, here we go, round two. Okay, we have our barrels, action and forehand together. Snap caps in place. Close the action. Fire both barrels. And now we watch for our timing. Let's see if you guys can see that. As we open the action, we're going to watch those hammers cock back. And you guys will see a significant delay. Here we go. Close it again. Let's see if we can see that again. Start opening. Open slowly and see if we can detect when those hammers start to cock. Open it again, slowly. There, that's when we start cocking. So you can see the barrels open a considerable amount here before those hammers start rotating counterclockwise. So let's take this back apart, and I'm going to show you guys what parts are responsible for timing, the cock on open timing here, and advancing that timing so that the hammers will cock sooner. Take the barrels off. There go our snap caps. I'll find out later. So here's what we have here, you guys. In our forend, we have this little surface right here. And let's take a closer look at that part. You guys can see kind of how that part is a casting. It's pressed into place. That's a separate piece inside of our forearm iron here. You can kind of see that radius right there. This thing was cast separately from our forend iron and then pressed into that little slot. And if you look at it from the back here, you can kind of see that it's probably dovetailed into place there. It looks like a dovetail is holding that tail end of it into the forend iron. And I'm telling you guys, that thing is pressed in there. I've secured it in my vise, tried tapping with some wood and some mallets, penetrating oil, a little heat. It's in there, you guys. It's a very cheap way to make these shotguns. And when that part wears, the timing starts to slow down on these things. Let me show you what that interface is like. Let's put the barrels back on and cock the action. Okay, you guys. Let's take a look inside of this action. These are our cocking arms. This is the front of them. This would be the back of them. Back here, they interface with the hammers to compress those springs and lock it with our sear and trigger. This surface on our forend when our forend and barrel fit together like this, it pushes back on those cocking arms when the gun opens. So, how do we resolve this issue and make those hammers cock sooner? Well, if that little piece that was slid in was just slid out maybe 100 thousandths more and then secured in place, that would pretty much solve it. But it's stuck in there. What I could do is drill or mill a small hole in there, set a punch into there vertically, and then try to knock that thing out, shim the back of it, press it back in, and set it with some 620 Loctite, green Loctite, and then call it. What I'm going to try and do is weld just a little bit of more material onto that bottom tab. I'll put a small bead right there to add material, shape it down, and keep clean it up so that there's an extra 100 thousandths of material right there. The more material I add, the better. We can always take material away. It's way harder to add material than it is to take away material. So, if there was just a little more material on that end there, the hammers would start cocking sooner when the gun is opened. That's how we're going to fix it. That's how I'm going to try and fix it. Now, cast steel parts can be tricky to weld on. We're not welding anything to it. We're just going to add a little bit of material and see if that resolves our problem. These guns were made very, 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 very cheap. And when they break, they weren't really intended to be built into cool-looking custom guns, or nice-looking custom guns. But this guy has the money for it. He picked it up. We're going to repair it for him and see if we can give him a nice-looking custom gun. Okay, stick around guys. I'm going to go set up the welding equipment and we're going to harden those firing pins. Stick around, you guys. Okay, so here's our 2 firing pins. I want to clean up the machining marks on these before I harden them. So let's bring them over to the lathe. Okay. I'm just going to turn this thing on and run some 400 paper over it. Okay, I'm going to get the torch set up and then we'll harden those things real quick. Stick around, guys. Okay, I'm going to start my torch, heat my pins, dip them in the hardening compound, heat them again, and then quench them. And we'll see how they turn out. Okay. Clean those guys up. That excess material off there. Test them with the file and see if they got hard. Okay. Here's our 2 pins after hardening. Let's find a small file and check how hard those are. Okay, they are skating across it pretty well. Okay, we're gonna go on to repair the cocking timing on this guy. And then after that, we'll go through a box of ammo and test fire and see if those firing pins break again. Okay, I'm gonna get this guy out of the fore end, set it up in our welding area, and then I'll show you how I can weld on that thing. Okay guys, the forearm iron is out of the fore end. I've got a little Dicom blue on that camming surface right there. I've worked it against the action, and you can kind of see where those cocking arms engage on the lug. I'll show you that right now. You guys can see how that fits together. And we don't have the tension to cock the arms back now because everything's disassembled. But you can see in there where those cocking arms bear against that lug, and that's where we're going to put that little weld bead right there, and then shape it down and reassemble it. We'll clean that marking fluid off of there and bring it over to the welding table. Okay guys, because this thing is cast steel, what I'm going to do is heat this up for a little bit and try to get it between 200 and 400 degrees before we start welding on it. I'm going to use a little butane torch for that. Here we go. And I've got a laser thermometer right here. It's at 81 degrees right now. We're going to bring it up to about 200, between 200 and 400. Okay, so we're showing 102 here, but this is getting pretty hot. It's already changed to a light blue. 20 and 30. $90. Someone back there? Okay, you guys, I'm actually quite happy with that. We didn't blow the edges of our part. And we added something of a little bit of more thickness. That we can work down and hopefully have enough material on there to advance the timing of that. Hold that cool down nice and slow. And then start working it and then check fit. Okay, we've got our part in our vise right here. I'm just going to file down that weld until we got a good flat surface. And then we'll fit it and try it. Okay guys, I'm quite happy with that. There is just a little bit of added length where that weld bead is, and that's all we need. Let's assemble it and test fire. Before we test fire, let's take a look at how that action timing is. You guys can see that those parts, we've got good fit for 4-end iron. Fits on our action nicely. It's not bound up. Putting our barrels on, putting our 4-end on. Okay, let's put these firing pins back in. And then we'll test fire. Okay. Let's put the barrels on, put the stock back on, and test fire. Okay, we are reassembled. Let's set you guys up in front of the test fire booth, and then we'll fire about half a box, about 15 rounds. Okay guys, I'm going to fire about 15 rounds, alternating each barrel as I load, shooting one barrel at a time. We're going to turn on the vacuum and kick this off. Okay guys, I got a little one failure to eject on that last round. We'll check that out, but come back, disassemble, and check out the firing pins. Okay everyone, here we are with our stock removed, our action relatively disassembled for access to these firing pins here. Let's knock these out and see what we got. Okay, that's what we got, you guys. Don't look too bad. They didn't break. I'm pretty happy with that. Let's take a look at the primer strikes on the test fire shells. Okay. Pretty good primer strikes. I don't really see any any drag marks that indicate that that firing pin drag out issue is still occurring. Okay, excuse me. Look like good strikes to me, good deep strikes. We're not breaking any primers. I'm pretty happy with this, guys. This was the first time I've ever done this repair. It is on a really cheap shotgun. You know, these things weren't really made to be repaired. They weren't built to be repaired. You know, you're supposed to shoot the shit out of them, sell them, get rid of them, trash them, whatever. But this guy wants to put some money into it. He's interested in a new stock pad, new stock refinishing, maybe some checkering, and a front sight. So stick around, you guys. We're gonna have some more work on this guy. And thanks for sticking around, guys. Looks like right now we're at 500 subs. That's pretty fucking cool, you guys. Thanks a lot. Thanks for sticking around. Thanks for the likes and the subs. That's firing pin drag out repair on a Rizzini over under shotgun. Stick around, guys. Thanks a lot. Thanks for the subs and the likes.